works at the same time. Hi guys, good afternoon everyone.
Yeah, good afternoon.
Hello everyone, good afternoon.
Good afternoon.
Yeah. Thank you all today, this morning, this afternoon, right now for joining us. This is the Bincom second quarter community event, and while we wait for that, I will just play an introduction video for us to see. So in the next 10 minutes or so, we should kick off with this fully. So thank you very much again.
Same time. This yellow dot represents a neuron in a neural network. It functions just like a neuron in your brain does. It takes in information and then gives an output. If this neuron takes in the information that says, hey, this person has a pulse, is breathing, then the neuron deciphers this information and says, okay, this person is alive. It learns to analyze situations where the human would be declared alive, breathing, or has a pulse, and situations where the human would be dead, where neither of those is true. That's essentially a bare bones explanation of how it works. Of course, no neural network is really this simple. Many have millions of parameters and are much more complex than just this one layer
Hello,
network.
Colin.
The world is full of sounds and visuals and just data in general. And we take
Hello,
in all
Colin,
of this
how you
to form our view of reality. However, as more and more complex topics show up with more and more data, it becomes harder and harder for humans to do this analysis on their own. This is where machine learning comes in handy. Machines can not only analyze data given to it, but also learn from it and adapt its own view of it. Let's go back to AlphaGo Zero. In only 40 days, it surpassed thousands of years of strategy and knowledge and even made up some of its own strategies. But how did it do all this? Biological neurons in your brain operate at about 200 hertz. That proved to be fine for us, but modern transistors operate at over 2 gigahertz, an entire order of magnitude faster. Those neurons in your brain travel through what are known as axons, and they travel at about 100 meters per second, which is pretty fast and gives us pretty good reaction time. But it's only about a third as fast as the speed of sound. Computers, however, can transmit information at the speed of light, or 300 million meters per second. So there's quite a big difference between our brain's capabilities and a computer's. In just 1 week, a computer can do 20,000 years worth of human-level research or simulations or anything it is trained to do. A brain has to fit inside your head. There's a limit to how much space it can take up. But a computer could fill an entire room or even an entire building. Now, obviously, weak AI doesn't require an entire server room to run. Like we saw with OpenAI, it only took a USB stick. But for more intelligent AI, it may require much more power. Artificial General Intelligence, or AGI, is AI with more than a single purpose. AGI is almost at or equal to human-level intelligence, and this is where we're trying to get to. But there's a problem. The more we search into it, the harder and harder it seems to be able to achieve. Think about how you perceive things. When someone asks you a complicated question, you have to sort through a ton of unrelated thoughts and observations and articulate a concise response to that question. This isn't exactly the easiest thing for a computer to achieve. See, humans aren't able to process information at the speed of light like a computer can, but we can plan things. We can think of smart ways to solve problems without having to brute force through every option. Getting a computer to human-level thinking is hard. We create societies and play games and laugh. These are all very hard things to teach a computer. How can you teach a computer to create something that doesn't exist or hasn't even been thought of? and what would be its incentive to do so? I believe AGI, or strong AI, is the most important artificial intelligence to be created, and here's why. Machine learning is exponential, meaning that it starts off rather slow, but there's a certain tipping point where things start to speed up drastically. The difference between weak AI and strong AI is millions of times larger than the difference between strong AI and super intelligent AI. Once we have the artificial general intelligence that can function like a human being, for the most part at least, it may help us reach super intelligence level in only a few months, or perhaps even weeks. But here comes another big problem. See, many people tend to see intelligence on a graph like this. We have maybe an ant here, a mouse at about here, the average human here, and maybe Einstein right here just above. If you ask most people where a super intelligent AI would line up on the graph, it won't stop at human level. It'll most likely just zoom past and continue getting on more and more advanced until, eventually, the graph looks something like this. This is what is known as the technological singularity, where artificial intelligence becomes so advanced to the point where there's an extreme explosion of new knowledge and information, some that might not even be able to be understood by humans. If we make a super intelligent AI, that AI would be able to improve upon itself, and in turn get smarter in a shorter amount of time, which means that this new and improved AI could do the same thing. It continues to repeat this process, doing it faster and faster each time. The first recreation may take a month, the second a week, a third a day, and this keeps going until it's billions of times smarter than all of humanity. Compared to chimps, we share about 96% of their DNA. We're 96% chimp, and that little 4%. We went from being extremely hairy and medieval primates to a species that has left the planet. We're a species that plans to colonize Mars, a species that made missiles and millions of inventions, all compact down into that 4% DNA difference. The number of genetic differences between a human and a chimp is 10 times smaller than from them. Their entire fate seems to lie in our hands. If we just do it, we don't ask. There are 5.51 billion ants on the Earth. Ants outnumber us 1 billion to 1, and yet we actually live like they don't exist at all. If we see one crawling on a table, we just smush it and move on with our day. What happens when the day comes where AI becomes the humans in this situation, and we become the ants? Super intelligent AI is different from software we know today. We tend to think our software is something that we program and the computer will follow our rules. But with highly advanced AI and through machine learning, the AI teaches itself how and what life is, as well as how to improve it. After a while, there
Are we still online? Hello?
Hello, sir.
It needs more information. Is it just going to make it up? This leads to what if the AI learns decides to lie to us about its accomplishments for its own selfish reasons? It's also possible that the progress of computing will slow down, and it looks like it already is. I mean, look at airplanes and past. Possibly turn the human species into immortal, godlike figures is coincidentally the same technology that could also cause the downfall of humanity. Many people are resistant to the AI because they fear it may have some of the negative traits that we humans do. It may be greedy, it may lie, it may be selfish, it may be rebellious, it may be short-tempered. The power of superintelligent AI is there, patiently waiting to be found. But the question is, do we actually want to find it? If we want the future to be perfect, if we want to create the perfect superintelligent AI, we need to be prepared. We need the smartest minds and the best strategies in order to create the perfect superintelligent AI. Learning.org is helping turn people like you and I into the pioneers of the future of humanity. Topics such as machine learning and artificial neural networks, aren't exactly the easiest things to grasp, but Brilliant does a great job at explaining each bit piece by piece. You can go in barely knowing anything about a topic and come up with a solid grasp on it before the day is over. If you're like me and are interested in the future of artificial intelligence, go check out Brilliant's courses on machine learning, artificial neural networks, and statistics. You'll be surprised on how easy they make it to learn. If you're one of the first 200 people to click the link at the top of the description, you'll receive 20% off of a premium subscription, and you'll be able to do as many of these courses as you'd like. We need smart people. So go get started today.
Okay, welcome everyone. Good afternoon, everyone. Kindly go to the chat icon. Can everyone hear me? Can everyone
Yes,
hear
I
me?
can hear you.
I can hear you.
Okay, if you can hear me, kindly go to the chat icon and put down your names, email address, and phone number. I stated it there that just put your name, email address.
Good afternoon. Good afternoon.
Good afternoon.
Dawn.
We must have heard about microservices prior to now. Probably this sounds new to us, and that brings us to the question: what is microservice? We can define microservice by looking at some basic terms. But one of those terms we look at is the XOA, which is service-oriented architecture. Basically, microservice is an architecture or way of developing software programs that has gained popularity in this modern times we have now. And if you ask an experienced developer what microservices is, it tells you that he or she tells that the person tells you microservices. It defines what a service-oriented architecture is for you. And like right here, we're just saying that it's a service that you split your whole applications or your whole application into several units so that each unit focus independently on a particular task, a particular function. Basically, that's what the service-oriented architecture is about. And in order to better understand this service-oriented architecture, and also understand the microservice architecture, we first have to take our approach on knowing what a monolithic application is, or what a monolithic approach is, or how we can develop or how apps have been developed using the monolithic approach. And for this walkthrough, I'll just give a quick example on using, um, assuming we want to create a hotel, we're working for, we're building a hotel software, for example. So the thing that we need to do is we run some SQL query because our hotel needs to fetch data from different sources, external sources, and so our hotel needs to make requests to add additional sources to the hotel. And lastly, those resources we display them to the users to see, unlike the clients. So when a user visit our website, for example, to book a hotel reservation, the first thing is that when the user search for hotel, we run through our SQL query based on the parameters the user put into that search box. We do some SQL complex query there. The next thing is, because sometimes it might not be in a database, so we have to connect to other databases or other services that provides hotels and lists for us to get more hotels. And the next thing again, those results we just display them to our users through HTML and template engine. So basically, that's the simple approach. Let's see how can work in a live scenario. Firstly, we say when the customer come in, we either get the customer's details, we can even register the customer and save the customer's details in our database if need be. And then the customer pays because he or she's looking for a hotel, make some payments, and then we connect this payment with our database or our banking service, rather. And then after that, we save this payment details also in our database for legal reasons. And next step would be we generate a receipt for this user, store this receipt somewhere else, and we send a message to the also to the user, stating the purchase or stating the ability for the deduction of debit in the user's account, and then also we store the send message also to our email service or hotel service. So these are just some features that our application will be having to understand what a monolithic approach is. I'm sorry if I'm going too fast. I might come back to things I've said before if you want me to. Lastly, we store everything again in our database to keep track of our reservation. So how does this approach looks like? How does it look like? How does it looks like? It's as simple as this. It's a very pure view of what like here having our application here. It connects to different services, and then also it connects to a single database where all the services in a single database. So basically, once a user visits the first thing the client sees is the client sees with the client request for place in Los Angeles hotel or something, and then the first thing to do is we connect to our party service to get more hotels from that location. And when the user make payments, we connect to our banking service to make banking reservation or to make payments, and then we connect to the email service also to send email to this user in the bank, and also third-party agents. All these things they are all stored in a single database. So you might ask, well, this thing looks quite simple. What are the advantages of using this monolithic data approach? Or I mean, this thing is very simple. What do we have to do with this kind of approach? We can see everything that our application is doing all in one go. I don't see any reason to leave this kind of architecture. Well, it's true because the main benefit of this architecture is that all our code, they are all in one place, and then it's also simplified for development. We're developing our code, we just look at one place, and then we see everything. So let's see some of the pros for using this monolith approach. One pro is that the monolith approach is very easy to create. You can start it as quick as possible. You don't have to put things return of thought into making the monolith approach. And also, as you can see, also we have a very centralized database here. Is centralized. Everything is stored in database. You don't have to worry about maintaining different databases. Everything is in one place. We have the users here, the hotels and based on reservation. You can get everything all from one database. So no need for maintenance on everything. And the very good part of it is deploying this application is very easy. you are done with creating your application, all you have to do is deploy a single instance of the application. It's as easy as that. You don't have to worry about where does this one fall in or where does this one fall in. Once the code is working, all you have to do is deploy it all in one go, and then you are done with it. So what's the disadvantages? What are some of the cons of this monolith approach? One of the cons is scalability. If, for example, we discover that our banking service or our payment service is getting more hits, or it's getting more workload than it ought to get, and we tend to expand this sector or this service here, we can just add more banking instance or payment instance to our application. We have to deploy a new application again. So everything here will be deployed. It will be another instance of all this application again. So that's one big disadvantage of the monolithic approach, because you can't do a single instance. You have to deploy everything. And also another disadvantage again is that as the code base grow, probably we're having more features to communicate to an airline service, communicate to a transport service, or communicate to different services, a restaurant service, and then we discover that all the code base is so complex and complicated that we cannot just think about them as a whole. And onboarding has become a problem because we can't grab everything at the same time. And another thing again is that you see, if you work on, for example, you want to change how the email service is being created, or how the email is being sending messages, or how the PDF files have been generated, and you change that file, it might be that it breaks down the whole service. Reason because the technology I'm using for this service might probably be so new or deleted, and it cannot work out with the other kind of services that you have in your system. So it might break the whole thing. And just make to emphasize again on this is that one of the top companies that is trying this approach, the microservice is Netflix. A very brief history is back in the days when there was one time in Netflix when a semicolon made Netflix spend several downtime just to find where a single semicolon was written in their own code base. That was when they were using this monolithic approach. So let's check out. Let's figure out what kind of things that we can do to break down this monolithic approach to become a better type of software. One thing that comes to mind is, why don't we separate these things so that maybe the service will just be a service on its own, and the party service on its own, party service on its own. And if you're thinking about that, that's when microservices comes to mind. This diagram might look complex. It's a very simple thing here where we have, when the user first comes to the website this time around, the user is presented with a booking UI. So when the user make a booking, the first thing is it goes to different services to perform different things. So each service is performing on specific tasks. For example, you can see this search service that searches for additional third-party hotels here. It's service on its own. So advantage of this is that a single team can work on this service and then forget about what the other teams are working on. That's a very good advantage. And you see the user service here has its own database. And basically, how we are doing here is we are separating all these services into their own isolated service. If one service fails here, it does not affect the other services. So we'll talk about also some of the advantages, or I'd say good advantages of this using the microservice approach. And one is this: for the microservice approach, you can work with several programming languages. It does not really force you to work on one particular language. So, for example, what I mean by that is that here we have the search service here. For the search service, it can be delivered by the PHP team, whereas the PDF reporting service might be worked on by maybe the Java team, and they work with different programming languages. But one thing in common is that they all have to agree on how they transfer the information back to each other, so they can see they will be using maybe ROPC or maybe HTTP protocol. They have to agree and say, okay, I'm going to be transferring this information to each other using maybe JSON. I don't know if my screen is up and everyone can see me. You can see what's on the screen, please.
We can see your screen. We can hear you as well. Please finish.
Okay, thank you. So as you can see, one very important thing is on sign here. And what about if we want to scale our application? What about if the payment method here got broken, for instance? We want to scale this payment method. The payment method is getting so much load that we will need to scale the payment method. It's a very simple thing to do to scale this method. All we have to do is we just deploy a new payment instance here to scale this payment method. We have to deploy our whole application. It calls for integrating continuous integration. So if one is working fine, and if this one needs to be changed, we just change only this one, and it does not affect the others. That's one good advantage of one microservice approach that we should all that's making almost all companies are going to using this architecture. I think this architecture as a whole has come to stay for good. So at this point, I would like to say I'd like to get the feedback from everyone in this.
You said you wanted to get a feedback, but we didn't get the exact question.
Yeah. I don't know if you know any questions to ask or anything. Good afternoon.
No questions from me so far. You were cracking a bit, but I believe you were asking if anyone had questions so far.
The microservices approach does come as a downfall, that pitfalls. We'll look at that at the end of the section. So it's an attempted approach on defining what a microservice is. We're saying a microservice is a lightweight application which provides narrowed features and narrows of features to well-defined contracts and its components single responsibility which can be developed and deployed independently. It's just an attempted approach on defining a microservice. Here again, I have the link to microservices, which I stated earlier. This is a separation of concept, meaning each team can work on a particular service without knowing the image of what that service is. So, because for autonomous team, smaller projects, you can't have everything in your head. You just work on something that you know you can grab the concept of at the time. You have to communicate with the other services with a very simple protocol. Just to call for continuous integration. Okay. I know most of us have come here expecting us to see some Python code and everything here. And before going to that, so I would like us to have do a very brief review on Python basics or the basics of Python and have some knowledge of Python. So here we have the SGI standard. We should know that it's used for almost all Python applications or Python framework these days. Use it to communicate with web server. So it's a simple interface communicating with web server. And one thing you should take note from some of the SGI standard here is that this work to gateway interface. It uses synchronous method to deliver its content. So it's not synchronous. It's synchronous. Almost all framework uses Python, O2, Flask, Django 2 uses this same API standard. That's been almost all frameworks uses it, even if they don't have it by default, but you can embed them with it. So the Greenlight and GVNet framework here, they're kind of anyway, or instead of using processes, this one uses threading to perform that continuous task here. The reason I'll talk about the difference between threading and processes when I talk about the language performance. For Twitter and Tolando, they are plainly asynchronous. Uses the asynchronous system here. They don't have to do with threading. They use processes to save their request. Whereas async is a very new concept. All you have to do is you just put the prefix async on the front of a function, and then it tells the function that this thing we are doing here will be an asynchronous function, and you can set concurrent request. The language performance, Python has something called GIL, and then General Interpreter lock. And what it does is it lets you do something called thread saves. And what thread saves means is you can run multiple instance different thread as a result. To get to a point where it blocks for other requests to be executed first. That's again what threads GIL is Python language performance here. So like I said, we're going to be writing some Python code here, and the service is going to be a very simple service to illustrate how microservices work. Services are just these services can be in different computers, so all you have to do is have a common base where they can communicate with. So the first one here is we build two microservices that work together, and we just call this service a message application, and the application uses Redis as its data store. And so if you don't know anything about Redis, we look at it in the So our application can do three basic things here. A user can come to the website and then send a message. Other users can see messages that have been sent, and also messages expire automatically. So they have a set time where we configure those messages to expire. So it's a very simple application here. And all the need for setup, we need Docker, Nameco, Redix, and RPC. And remote procedure calls anyway. It's not really there for the but I highlight it here because the concept of RPC is needed to understand how microservices work, or in particular how Nameco works. Nameco. We've seen different frameworks. We've seen framework like Django, Flask, Tornado, and Twisted, but Nameco is a very new one to us, and we were surprised why this framework is gaining popularity now. It's because this framework is built with having microservices in mind. The developers of this framework, they built it with the intention of creating microservices with Python, and all it does is it uses the RPC protocols to communicating with other services, other microservices via the advanced messaging and queuing protocol. So basically, how Nameco is just a framework developing applications that are microservices in Python. That's just a simple definition of Nameco I'll be using. So I'm not saying that you can't use other frameworks like Flask, Django, or Bosu, but I find Nameco very convenient to use, and how easy it is to spin up these services, and very importantly also how Nameco uses this RPC and remote procedure call. Because if you check out the memo of SOA in their website, there you find what microservices are, or what it is rather, but they didn't define for us how these services can communicate to each other, or even how the services can send messages, or how kind of messages that these services should be receiving. They tell us if they should send messages as JSON, YML, or even SML. They just said they can communicate with each other, but not even the protocol by which they can communicate. Now, RPC stands for remote procedure call. The remote procedure call is the protocol that enables two programs to communicate to each other. So one program sends a request to a service, and then even if that service is located in a different computer, as far as it knows way to locate that service. They send a request to that service, and the link and the service there understands what the request is, and then send back a response. It's as simple as that. It's a communication protocol between services, and to use this protocol with Namco, we have something called the advanced messaging queuing protocol, because that's how it works. When the messages are sent to the services, it goes to this advanced queuing protocol. Okay, I think I talked about this before. So as simple as this, on RPC here, the procedure call. So as simple as this, you see here a very familiar code that we know. We have this function here called new booking. Talking about maybe a booking. This is a hotel. Maybe this is a transportation booking service, for example. So you have the user ID here, you have the location of the person, which is the base, destination, and time. So once the person make a new booking request here, so we have a service that sends email to maybe the customers or maybe to a third party. We just call the service here and say service just send email, and then it's as simple as that. We communicate using as if we are calling our own local function, whereas we are calling a remote we are making a remote call to another computer somewhere else. So as far as this simple line of this simple line of code, how make a remote procedure call using communicate with processes using the procedure call. Definitely, it does not come without a drawback anyway, because one major drawback with the procedure call is that you don't know when you are talking to other services. It's quite computationally expensive. You just call, you just know you don't even know making the call. You just call it as if you're calling the function. Once you call this thing now, it's going to communicate, or it needs external resources from since it uses network connection, it needs resources from the other system to make this call. So it can slow down things sometimes. And when we use this kind of connection, when we use this kind of connection or RPC procedure call, we should make sure we differentiate it, or make sure know that this is that we are making a procedure call. Next, I just be consuming so many network bandwidth. When a service send a message to another service, it stays in a queue, and that queue stays on. Nico has its workers that all it does is they go to that queue and see if there's any service link there or any request link there, and then they take in those requests and process it and send it back again. So basically, how it is a service sends a message to another service, and that message is staying in a queue where this Nico service workers just go there. Nico spawns up a new worker. They say, hey, there's a new request here. Go work on that request, and the request is being worked on, and just like that. But something you have to note again is that if several requests are being sent, or so much requests are being sent that the Nico service has exhausted all its workers, then the other additional. So the limit can be set anyway by we can set the limit ourselves. A good tool to utilize the AMQ procedure is it's the MQ. It's a popular tool for utilizing this. And how we're going to utilize this is very easy. We're going to install MQ using Docker. We saw right now a requirement by there. And what Docker is just a containerized environment for our applications in isolation. Okay. So within Docker, everything that we need to run the code is already there. We don't need to install any other dependencies. The important thing with Docker is you don't have to worry about different installation procedure or the kind of error pop up when you're to install a new application or software. Just run it from the containerized environment. Anything that's already pre-built you don't need to you don't get any errors when you are doing that. Is running this file here in demo mode, or this image here in demo mode, and P is saying that I want to connect this port from in Docker to the port in our PC, and same thing here, connecting the port in Docker and container to that in our PC, and passing it a name here called RabbitMQ. And that you from the Docker up here. So the first thing it did was it checks my Docker image to see if I have
I think it got disconnected. It will be back shortly. Are we on?
Yes, sir.
Okay. Welcome back, Vince. You got disconnected for a bit.
yes, yes, sir. Please come. My screen is up.
We can see your screen.
Okay, thank you. So I was explaining how Redis working. I mean, when I mentioned that to run our programs, we see the inbuilt storage, or the place where our variables have been stored in in memory. That's all what Redis is. Redis is not a persistent data storage per se, but it just allows you to store in memory using the key and value method. And why do we have to use Redis for this application? Because it fits very well with the kind of application we're trying to create. Don't forget, application just have to store a message and then display that message in our main website page. And also, one thing again you know about Redis is the operation is O1. It's very fast. So the contact complexity is O1, extremely fast. You provide the key, then it gives you the input for the key value. Redis also have other time complexity algorithms that you might want to look at, and one that is highly discouraged anyway is the one that does do with displaying all keys, which I would look at when we write the program. So installing Redis again on so install it again on the document starts quite format the previous we run the other time. So I don't know if anyone blessed with the new information that we've gotten, and it's not at this time we move on to seeing some code. And before we do that, let me show you what I came up with quickly. So we don't use anything. So this is what I came up with. So not the best front end dev here, but this is to it. The user comes to the website, user type in a message here, and then post the message on our website here. And it displays all the messages that are stored on the website. It's a very simple application, but the key here is we are defining how to implement microservices here, where different services are communicate to each other. So we have two different services. One services and those users web requests, and another services and those the message request. And we'll see how we can put all that together using our Python code here. Very good. So I have a root directory here called microservices. And in this root directory, I have additional directories here. This one is not included anyway, it's from the Python I was running. So we have one here called the requirements from directory. We have the text directory, we perform text for our program. The requirements here has everything has to do with all the requirements our program needs to run efficiently when we use them Docker to analyze our application. And lastly, we have the time it messenger, which houses the core functionality of our program. So I'll quickly check on requirements.ts file. So this was here. Here we are having 4 files here. The base.ini, which I open here, and the text.ini here, base.tst, base.in and text.in. So basically, what this is if you are going to the normal way to create a requirement file is to create a file called requirement.txt and place all the dependency you want in that file. But for now, for this point, I was using a tool called pip setup. I think pip setup. It's a command line tool that all it does is you give it a file name or the dependencies you want to install on your PC or on the program. So here I'm using the virtual environment to create my program. So I created this names here. I want to get this file or this library called Limco, the library called Redis, and the library called Ginger. Limco is our framework, like I said earlier. Redis is data storage, and Ginger, if you ever work with frameworks like Django, you have used the Django template several times. Right.
Could you repeat the last thing you said? Am I up next?
So I believe everyone can hear me. And I'll continue.
I can hear you, Collins. I think I lost you for a few minutes now. Can I hear me, please? Hello.
Yeah, hello there. I think
Oh,
my screen is down.
okay. Sorry, you got disconnected. Should I start? Something? Please, can anyone else? Because I'm not sure. No. Hello, everyone. Can anybody just trying to make sure I'm on? I can see everybody else is on mute, so you need to unmute yourself if you are speaking. Hi. Not really. Anybody else? Anybody else? I'm sharing my screen. Just open up there. So please confirm, can you see the screen?
Yes, I can see your screen.
All right, thank you. So good afternoon, everybody. My name is Bade Adesemowo. I'm CTO and co-founder of Social Lender. I will take a very short section about microservices, and I put a small caption to say software. It's actually an ideology. Collins has taken us through in depth about microservices, about the fact that the difference between
I can't see your screen here.
Hello, Mr. Kolo. Hello. Hello, Mr. Kolo. That's all that let's just go to this the first one we have to take we have I should not forget to mention having conflict in presentation. I have this right now I'm running system report for the queue, running report for the so I have to do that usually. Most of the I have about 6 this RPC is how we using these procedures called the code. When I visited the website, you can put other things that you can concentrate on this particular one. Different messages. to do works about having and we have this injection here for the message. So this message removes all my first message service. So this message was actually what it is the Reddit this class here creates a abstraction for see the complex thing that's happening or see just and if you would like to see that looks like the place that's capacity key. How how the rates work. I'm not sure that right now, but how rates work in this way. That they want to set a key with this one called maybe a key called name and one called callings. That's so this is very funny. To set a key right, I would just say you set a key called name. I would then set the key name and you try to get all of the get names like the name that's like in this abstraction for us. So it sends the message and then returns it. And something useful is that we have this as RPC protocol attached to all the methods. It just tells this thing that we are exposing this point as entry points. So other microservices can use our microservice by directly referring to this entry point. It can call and it gives us a message that key. Same message is ready set and the get is all it does is using the function and I said this function is not use this function very likely not the same finish for it is that this method found all the keys stored in the database. Command here called keys. All the keys are stored in this command in this database. So the database is different database numbers. For this one, using the phone number is 0. Database so it for the and how does the website is to set this thing now, but it can be different. But at the competition. So it's it's going to be same key running on a different itself, and it can so how does it with the message service? Again, we have brand name or the name that we as server, and you see how easy it is for us to call to connect to this message service here. Again, this here is the abstraction they give the abstraction into that using templates like we'll do let's see here that I posted by using the arrow of the current using the using this here or these entry points here. So and as you always do it we are using message class message created make a remote call that the service the message itself here. And when we did the call here, the message from that call. But this point is exposed to us that are received the call. We are very simple. And like I said, these things are in different so you can make that call directly and that's fine for us. But it has to pass that different remote call here or call here and get that post to the same messages. All this is the same method and we also wonder that we are having things like email responsibility. Also has several dependencies community effort that I can go to sorry to create this language for us. Bottom here and for send that's how it is for the great objective in our sense to find that remove the I just use a call all as if we are inside our system. It's out of Docker instance running. Wrong. So, I'll talk about the Redis and thank you very much for checking this out and see this source so intelligence matters to my box. And also, it's a mentor to me because yes, I think that I don't really know any family at the concept instantly. So the knowledge of everything is something you want to ask and when is I'm trying to achieve. Um, hi guys, how did you guys just in a moment? So before we close, since we've seen what microservices have and how microservices can connect to each other, I'd like to talk about the pitfall of microservices. So I'm not saying microservices is the best thing, but I think that the best thing that have come to stay and they are going to stay for a long time because it is our way of building software applications. So one of those pitfalls for microservices
is that because of illogical splitting. So if I ever working on an application or software that calls for moving that application from a monolith to a microservices, the first thing first is that if you have any doubt that that application will be split, please and please just neglect splitting the application, because if you split the application wrongly, you might realize that in the first place you don't need to split the application, and then it will cause several overhead. And another thing again you should notice that when you split the application wrongly, or how do you know when you split the application wrongly? If you make changes to one service, then you have to deploy another service again or make changes to another service. That's another way to know that you split application wrongly. And also more network interaction, because these services are not in the same machine. They have to communicate through different networks, and it causes enough network computational power and storage and data sharing. It's a big problem, because you have to ask yourself that, okay, if you have permission, like we saw here, for example, a user in the user's database, do we duplicate information also to the banking database? The database. So data duplication is a very big challenge for microservices, and it's something that people have to put in several thoughts about before um, arriving on an architecture that works. And lastly, again, it's called compatibility. The changes you are making in one code here, in one code base, in one service, how compatible it is with your service. When you're using this latest one, is it does it get so fast that the other technology or the other services can meet up with it? Is it an asynchronous call you are making, or synchronous call? So these are compatibility issues that we also look at. And for testing, making integration testing in microservices is very difficult, because testing in general is very hard. You have to test several units, test those functional testing, integration testing, end-to-end testing. So this thing is very hard, and it's complex for microservices. Like you saw for monolith service, you can do everything just in one go, and it's easy. But for microservices, things are quite complex. So those are the some of the common pitfalls for microservices. I want to say thank you very much, everyone, for joining this section, section this quarter. And I'd like to say, if you have any questions to ask me, you can find me on this channel, and you can also find us on the Bincom and the Center team. And I'd like to give Chisom a chance to um, talk more about the Bincom Dev Center and what we do here. Thank you very much.
Okay, thank you, Collins. I'm trying to share. Okay, thank you once again. I just want to say one or two things concerning Bincom Dev Center. As you can see, Bincom Dev Center is a multi-location based training and development center for technology solutions, and here are the services we offer at Bincom Dev Center. We have Bincom Academy, um, class where programming classes and some sort of classes are being offered based on a Montessori approach in training participants the skills needed in our technology ecosystem. We have the Income Tech internship, which is designed to enable people to, at the intermediate skill level, gain um, mastery and expertise over a period of time. The Income Tech apprenticeship is an industrial attachment where people get to learn on the job. The Income community events, which is what we did today, we did in giving back to the society and building the tech ecosystem. We have the Light Space, is our co-working space and event space. Provides helpful workspace needed to encourage collaboration in startup ecosystem. People get to rent our light space and use it for events, board meetings, conferences, seminars, and whatever. These are some of the images that are light space and um, Bincom Academy, our community events, and so on. Then these are our upcoming trainings. We have classes, um, registration for our Bincom Academy classes. At Bincom Academy, we offer the PHP, Python class, mobile app class, project management class, web development class, infrastructure class, graphics class, and digital marketing class. The class rate is 6,000 naira. Though now our classes are online for now, and it goes for the online class goes for 10,000 naira. Um, these are upcoming events. Today we had the Python meetup. Next week, 17th of this month, we're having the PhD meetup to do well to register. Um, we have some other events coming up, the cloud hosting meetup, income startup school, Angular meetup, social lender, digital financial service masterclass, ed tech meetup, income ICT, career talk, digital marketing meetup, data science, e meetup, and DevOps meetup. Okay, questions and feedback will be highly appreciated. Thank you for listening. Hello?
We can hear you. Thank you.
All right, that's all. That's the summary on what we do at Income Dev Center. Thank
Thank
you
you very
all
much, Isam.
for attendance.
Thank you very much, Isam. And, and thank you everyone for joining this meetup today.
Thank you. Apologies, my connection wasn't working well. I actually did my entire presentation, but apparently it was just to myself. But thank you, everybody. See you at the next one.